In this section, we want to talk about more opportunities for savings and investments. So far, we've talked about cases with simple interest, where we apply interest once for the life of a loan, or since we're talking about savings and investments, once for the life of an investment. We also looked at compound interest, where we apply interest once every compounding period, whether that's annually, semi-annually, quarterly, etc. But so far, these cases have been a little artificial because we've dealt with cases where people put a single deposit, which is sometimes referred to as a payment, into an account. That is possible, but lots of times people actually save by making recurring payments into some savings account or an investment. That's what we want to focus on in these next few examples. When a deposit is made at the end of each compounding period, that type of savings account is referred to as an ordinary annuity. We have an example of an ordinary annuity in example 1 because we're going to be looking at deposits going into an account monthly and interest being compounded monthly. We note we need that deposit period and that compounding period to be equal in order to have an ordinary annuity and for this function to apply. So in example 1, we're going to be looking at calculating the future value of an investment, which will be calculated as capital F of lowercase p for that monthly payment, times an interest rate R, times a time period in years, T, and a number of compounding periods per year, N, will be equal to P times 1 plus R over N, that quantity raised to the NT power, minus 1, all over R over N. I already have this formula plugged into Desmos, so we'll switch over and we'll plug in the values in this problem. So we're looking at a monthly payment of lowercase p, which is $300, into an ordinary annuity with a 0.375 interest rate for 20 years, compounded monthly. And we get a future value of $106,994.47. In example 2, we want to use all of those same values, but now change the amount deposited and the interest compounded quarterly. The interest to be compounded quarterly. So we'll change our value for N from 12 to 4, and we get a new value of $35,507.73. This result is quite a bit lower, but keep in mind, like we talked about in example 1, the depositing period and the compounding period have to be the same. So in this case, if we're compounding quarterly and depositing quarterly, rather than depositing that $300 every month, we're only depositing once every 3 months, and interest is only being calculated and applied to our principal every 3 months, or 4 times a year. So we're investing less in this account, and interest is being applied less often, giving us a lower future value for that investment.